I was watching a YouTube short recently where someone turned a portrait into a mosaic using Rubik's cubes. It looked incredible, but the logistics of doing that by hand are a nightmare. The problem is that to get a recognizable image, you need resolution. And in this medium, resolution equals money and of course time. If I wanted more detail, I need more cubes, and suddenly I'm buying thousands of them and spending days twisting every single face. It got me thinking, could I do the same thing but on a computer? To get this working, I first looked at the cube itself. I'm not talking about the mechanics or speed solving, but strictly the palette. I don't have the luxury of millions of shades or smooth blending like I do in a standard JPEG. I'm stuck with exactly 6 high contrast colors: the white, red, green, blue, orange, and yellow. A standard Rubik's Cube has 6 faces, but for this project I only care about the one face pointing at the camera. That single face is a fixed 3x3 grid containing 9 small stickers. So while I have 6 colors to choose from, those colors are mapped onto those 9 specific sticker slots per cube to build up the larger picture. Now, in the world of computers, the image I want to represent is just a massive grid of pixels. Every single pixel is a mix of red, green, and blue values. Real photos have lots of shadows and mixed colors, which is a challenge. How do I match a light skin color when I only have bright orange or white stickers to work with? Now, this is where I used mapping. I mapped these mixed image colors to the simple cube colors using a process called Euclidean Distance. You can imagine every color as a specific point in 3D space. For every single pixel in my source photograph, I measure the straight line distance between the pixel's color and my 6 available colors. Now, if I have a pixel that represents a dark ocean spot, I found that the distance from that pixel to red or yellow is a huge number, which is a big error. But the distance to blue is very short. I simply look at every pixel and assign it the color with the shortest mathematical distance. Now, to make this efficient, I altered the image as a matrix. If I tried to do this one pixel at a time using a standard loop, it might take a while. But instead, I loaded the colors into a grid, essentially a giant spreadsheet for the computer, allowing me to process these distance checks for the entire image instantly. I convert the whole photo into my 6 color palette in a very short span of time. And once the colors are decided, I had to make it look like a mosaic rather than just flat pixel art. I drew 2 different types of grid lines. I drew very thin lines to separate the individual color stickers, and then I drew thicker gray lines every 3 spaces. Now these thick lines represents the gap between the cubes themselves, visually separating the 3x3 grids. I determined the size of the final image based on how many cubes wide I wanted the mosaic to be. But I encountered a logic check I had to handle. Cubes are discrete units. I can't have half a cube at the bottom of the wall, and so I handled this with an offset cutoff. I worked out the target height based on the image aspect ratio, and then I checked if the height is perfectly divisible by 3. And if I faced a height that results in a partial cube, I just stripped away the remainder to ensure I strictly have a full 3x3 blocks vertically. The quality of the final results depends entirely on the cube count. If I use a low number, the image is blocky and unrecognizable. And the higher the number of cubes I use, the better the mosaic looks because I have more stickers to represent the details. Now, this is more memory intensive because I have to process that Euclidean difference for way more pixels. But unlike doing this by hand, where doubling the resolution quadruples the cost, here I just use a bit more processing power. When I set the parameters to something like 100 cubes wide, I generate a massive mosaic. Since each cube is 3 stickers wide, that gives me a horizontal resolution of 300 stickers. The result is a massive grid containing thousands of individual color patches that create a surprisingly clear representation of the original image that was generated in a couple of seconds. If you want to try this out for yourself, the link to the project is down in the description below. And this was, as always, a cool and fun project. Nothing too serious, just try new cool things all the time. Thanks for watching, and I'll see you in the next one.